Ampere's law is very similar to the Gauss law, which we have discussed in electrostatic chapter. So what we did in the Gauss law, we have calculated electric field for more symmetrically charged bodies. And in the same method, we will follow in this chapter, that is called your Ampere's law. With the help of Ampere's law, we can determine magnetic field at all those points which are symmetrically placed between or symmetrically placed about symmetrically current carrying charge conductor. So Ampere's law is very simple method to determine magnetic field due to those charged body or those current carrying conductor in which current is flowing symmetrically. So first of all, before calculating before discussing the Ampere's law, we can write it is a method to determine magnetic field due to symmetrically located point, due to symmetrically current carrying conductor, at symmetrical position. It is a method to determine magnetic field due to symmetrically current carrying conductor at symmetrical position. So first point here regarding Ampere's law, Amperian loop. So what is the meaning of Amperian loop? As in the Gauss law chapter, we have used the Gaussian surface. The Gaussian surface was a closed surface which encloses any charge or does not enclose any charge. So we have to make any random surface of any shape and size in the Gauss law. Similarly, Amperian loop means we have to make a loop, and that loop can enclose any of the current carrying conductor or not. So we can write Amperian loop means it is an hypothetical closed loop of any shape and size, which may or may not encloses any current carrying conductor. It means, let for example, we are having certain current carrying conductor in which current is your I1, I2, I3, like this. So I1 current indicate means current is your inward. Cross sign indicate कि our conductor is your normal to the plane of this board, inward direction current. Dot sign indicate कि our conductor is normal to the plane of board but current in your outward direction. Similarly, I3 also indicate cross indicate current is your into the plane of board, inward. Our conductor is your normal to it. So Amperian loop means any of the closed loop of any shape and size. So we can have this just like a one closed loop. That can be also said as an Amperian loop. This can be also said as an Amperian loop. Or if we want this to, this can also have any Amperian loop. So Amperian loop means any type of such loops we can make, because these loops are hypothetical. These are not any particular shape and size. So as per the requirement or as per our need, we can make our Amperian loop. So normally our Amperian loop should be symmetrical about current carrying conductor. Then our purpose can be solved easily. But in general, our Amperian loop can have any shape and size which may or may not encloses any of the current carrying conductor. So first what we have to do, while we are using the Ampere's law, first we have to make Amperian loop. After that, see the Ampere's law. Now see Ampere's law. So according to Ampere's law, the line integral of magnetic field over a loop, the line integral of magnetic field over an Amperian loop must be equal to mu naught times current enclosed by the loop. Current enclosed by the loop, provided electric field within a loop should be constant. Within loop should be constant. So according to this rule, B dot dl, that is equal to your mu naught I enclose, and here we can write electric field is constant provided. So this is the actual meaning of Ampere's law. So B dot dl, it means we have to find dot product of magnetic field over a loop. dl means the distance traveled in any of the loop, and this sign indicates your complete integral, means for a complete loop. Any of the loop we can select for that loop. So B dot dl for that particular loop must be equal to your mu naught I enclosed, the current enclosed by that loop. This is the meaning of Ampere's law. So before applying Ampere's law, first we have to use certain sign convention, which type of sign or what value we have to consider here as positive and negative. See. So now according to Ampere's law, B dot dl is your mu naught into I enclosed. So B dot dl means here, so we are finding the line integral or circulation integral, means this round sign in the integral is indicate we are doing this dot product of magnetic field with the dl around a whole Amperian loop. It means we will calculate B dot dl for any one of such loop, like this one loop, or we can say this is another loop, or like this another loop, is equal to mu naught I enclosed. But when we are talking about the current I1 and I2, see, cross indicate current to your inward to the plane of board, and dot indicate current to your outward into the plane of board. So which current we should take, positive or which is your negative? For that we are having a certain rule. So first we should know the proper rule here. So what we have to do, first step. The first step, define your direction in a loop. Define your direction in a loop. In a loop, your direction means either clockwise CW or anti-clockwise we can say ACW. So once you have defined your direction either clockwise or anti-clockwise, then in the second step, use right hand thumb rule. Right hand thumb rule. So according to right hand thumb rule, rotate your finger as you had defined your direction in a loop. Then the direction of thumb give the direction of current. In the direction of thumb, whichever current is there, that current should be taken as positive. So use right hand thumb rule. According to this, rotate right hand fingers in the direction of your defined direction. In the direction of your defined direction. Your defined direction. In the direction of your defined direction, then see the direction of thumb. Direction of thumb. In the direction of thumb, current should be taken as positive. Current should be taken as positive. Should be taken positive, and opposite to thumb direction, current is negative. Current is negative. This is the rule. So it means once we have defined our direction, then rotate finger in that direction, then see the thumb. In the direction of thumb, current should be taken as positive, and opposite to that it is taken as negative. If we are looking for first loop, let loop number 1. For first loop means that loop is this. This is the loop. So in this loop, I am defining clockwise. I am moving in the clockwise sense. See, if we are moving in a clockwise sense like this, so our thumb here into the plane of board, so I1 is in that direction, so that should be taken as positive, and I2 are opposite to that, that should be taken as negative. So for first loop, we will write B dot dl is equal to mu naught I1 minus I2. This is the meaning of I enclose. Similarly, if we want to apply in the second loop, let this be your second loop. So for second loop, now B dot dl in the second loop. So first, in the second loop, we should define our direction of motion, in which direction we are moving in a loop. Either clockwise, one option is there, another anti-clockwise, another option is there. That depends on your wish. So if I am moving in the second loop your anti-clockwise. So according to that our defined direction in the second loop, see, anti-clockwise, just apply the right hand thumb rule. So finger in the direction of current, in the direction of your motion here, like this, anti-clockwise. Then see the thumb. Thumb your outward. Outward current in the loop is your I2. Inward current your I3. So I2 taken as positive. I3 is your negative. So for second loop, we have to write mu naught I2 minus I3. This is the meaning of that. And if we are looking for third loop, let this be your third loop. So for third loop, there is no enclosed current in the third loop. So that should be a 0. So important point is that in the third loop, current is 0 does not mean that magnetic field at any point on the Amperian loop is 0. The dot product with the dl is 0. So this is the first rules of using I enclose and taking the direction of B, all this. Apart from that, when we are talking about the B is the magnetic field where at different point on the Amperian loop. See, after rules, now see the all description of these points. According to Ampere's law, B dot dl is mu naught I enclose. So after using the Ampere's law or using sign convention, first see what is the meaning of B. B is the magnetic field at different point on B is the magnetic field at different point on Amperian loop due to all current carrying conductors all current carrying conductors means either due to all current carrying conductors, either conductors are enclosed by the Amperian loop, or outside it. So in general, Ampere's law can be said as written as B dot dl, meaning is this: B1 dl1 cos theta 1 plus B2 dl2 cos theta 2 and so on till complete loop is not covered, which is equal to your mu naught I enclose. So meaning of B1 dl1 is that, suppose if we are following the first loop and we are here, and that is your dl1, very small length, very small element in the loop. So at this point, when we are calculating magnetic field, due to the current some value of field is there, due to current I2 some value, due to I3 some value and direction. So B1 is the magnetic field at this point due to all current carrying conductor. So let B1 is your in this direction, and as per the rule, if we are moving your clockwise, so we are going in this direction. So dl1 this direction, B1 this direction, so this angle is called angle theta 1. Similarly, suppose somewhere if we are here, as our position changes from different current carrying conductor, so definitely magnetic field value as well as its direction will also change. So B2 is the field at this region, dl2 is the length of this, theta 2 is the angle. Suppose this is the B2 and this is your dl2, so this angle your theta 2. So likewise we have to do throughout whole Amperian loop, then we will get a mu naught I enclosed. But how to use this Ampere law when we have to calculate the magnetic field due to current carrying conductor? So what can be done here? If we are able to make such a loop which is symmetrical about current carrying conductors. So if we are able to make such a loop which is symmetrical about current carrying conductor, so at each and every point on the loop, magnetic field value can be equal in magnitude, as well as if we are able to make such a direction in which theta value for everywhere is 0, so it will be easy for us to calculate the magnetic field due to such current carrying conductors. So this is the main objective of your Ampere's law. So with the help of Ampere's law, we would like to calculate field due to symmetrically placed current carrying conductors.